All right, so today we're going to begin our series of the 5 topics that we are anticipating to be the most important in SPM, most important in terms of the essay lah. Okay, in terms of the essay, I would consider this to be the 5 most popular topics, which is a good point of starting lah. Okay, so let's go into the topic of forces and motion 1, and we're starting with the Kedah paper 2023. Okay, as you can see over here. All right, so diagram 6.1a, 6.1b show a trolley moving down an inclined plane with a different height. Okay, what is meant by momentum? Okay, momentum is the product of mass and velocity. Okay, generally there will be 2 kinds of students that come into sessions like this. Number 1 is either they have answered the questions, means they have already done the preparation and they just want clarification of the answer, to which your job will be much less okay, in this class. Or you are coming into this session to study, okay, which means that you're taking things down as you go along. So if you're the first group of people, then all you need to do is check. If you're the second group of people, my suggestion would be you copy down all the answers as I give them, and then after that review them. Okay, that's why we have breaks in between, okay, so that you can review the answers as part of your study session lah. Okay, either way, whichever way you are, this is not the place for you to, ni yang lebih baik dia lebih baik daripada saya. Tiada lah, there's no such thing lah. Okay, everybody is studying at their own pace, at the pace that they are manageable, that they're managing in, and all I'm doing is just, making things easier for you lah. Okay, either by giving you the answer or to provide you a guide. Okay, so take it as it comes lah. All right, our next comparison question, I think this should be quite easy. If you look at the diagram, everything in 6.1a seems to be less lah. Okay, so 6.1a is less than 6.1b for the height. Okay, for the velocity, obviously if the height is less, then logically 6.1a will be less than 6.1b, although there's no indication in the question at all, but you should be able to infer it logically lah. Okay, therefore the momentum, since the velocity and the mass is both less, since the velocity is less, so the 6.1a is less than 6.1b. Okay, same kind of trolley but different velocity, so the momentum of 6.1a would be less. Okay, relate the height and the velocity. So again, when you're doing a relation question, remember that the order matters. Okay, the bigger the height, the bigger the velocity. Okay, I'm only going to give short form answers like this I hope that it makes sense to you Okay, remember again, everybody, in this question it's quite easy because the height comes first and then the velocity. But just be aware, okay, that sometimes the questions can switch it around, so you may need to make sure that your relationship, okay, makes sense State the relationship between the velocity and the velocity of the trolley, okay, and the momentum. So this one will be velocity has to come first. So the bigger the velocity, the bigger the momentum. Yeah, I know, sorry. My writing is in holiday mode, so yeah, anyway. Either way, this is a very simple question, I think. Okay, it's a comparison question. We've been doing this since a long time ago. Okay, so I think it should be okay. All right, diagram 6.2 shows a strip of ticker tape for a motion of a trolley with a mass of 4 kilograms. Okay, just noting down the mass is here. Frequency of the ticker timer used is 50 hertz. Okay, now why is this 50 hertz very important? 50 hertz is very important to tell us that the time taken for one tick, okay, over here is 0.02 seconds. Okay, this is a very important relationship. Okay, the fact that one time taken is 0.02 seconds is given because the frequency of the ticker timer we use is 50 hertz. The good news is, in our syllabus okay, generally we use 50 hertz. We won't use less than 50 hertz or more than 50 hertz Okay, so at this stage, okay, because we're just preparing for SPM, just remember that if you see 50 hertz, means one tick over there is 0.02 seconds. So if you count the number of ticks, Okay, 1, 2, 3, 4, 5, 6. There are 6 ticks altogether. So the total time over here, okay, the total time will be 0.02 times 6, which will be 0.12 seconds. Okay, so based on the ticker tape, count the velocity of the trolley. Okay, so the velocity will be the displacement over the time. So it's 10 divided by 0.12, okay, which will give you about 83.33. In this case, you have to use centimeters per second. Okay, if you're going to use meters per second, okay, give you the alternative, then you have to change the 10 to meters. 10 cm will be 0.1 meters divided by 0.12. You get 0.833 meters per second. Okay, either way is fine. Okay, even using the centimeters per second is not wrong because you're using the correct unit. Okay, the question doesn't specify calculate the velocity of the trolley in meters per second. If they give you the unit, then you have to change it. But in this case, it's easier because it's free. You can choose centimeters per second, you can choose meters per second. Okay, then calculate the momentum. Momentum is the product of mass and velocity. So our mass given over here as 4 kilograms. So it'll be 4. Okay, this is the thing. When you're calculating momentum, unfortunately, you have to use meters per second. Okay, generally. Okay, so in this case, if I use meters per second, it'll be 0.833 meters per second. Okay, and this will give me 3.333 ish lah. Okay, 3.333 meters per, kilogram meters per second. Okay, so of course the question then comes, what if we use 83.33? Because your velocity is 83.33 if you calculated using centimeters per second. Sure, no problem. Actually, I don't think it's a problem as long as you get the unit correct. Okay, so if you, let's say you use P equals to mv once again, and this time the P I use 4, but my V I use 83.33. Okay, which is over there. Then I will get an answer of 333.33. I think the 2 should appear somewhere over here. Totally fine, except that the unit will be kilogram, and our unit for velocity is what? Centimeters per second. Okay, this is also an acceptable answer. So everything really depends on what unit you're using. Okay, and this is usually where people fumble up. Okay, the only problem is this, well, it's not really a problem. I think it's a good thing. There is only 1 mark. So even if you get the unit wrong, at least you didn't lose that many marks. Okay, I would actually caution more on the first one, because it's 2 marks. So that means 1 mark is for the working, okay, and then 1 mark is for the answer with the unit. Okay, so wrong unit, then you will not get the answer. Okay, be aware of this. All right, let's move on. We're going to Perlis 2023. Okay, question number 2. Diagram shows an egg dropped onto a wooden block. The egg cracks after the impact. The velocity of the egg just before the impact is 5 meters per second. Okay, just before the impact is 5 meters per second. So then the force involved during the impact. Whenever you see the word impact, there's only one force involved, which is impulsive force. Okay, impact during collision, then the force involved is impulsive force. Okay, just to be clear, momentum is not the force. Okay, because I've seen people, they think that momentum is a kind of force, and because there's an accident involved, there's a collision, so the force must be a momentum. That's not the case. Okay, momentum is momentum, a different story. But force, of the many forces that you study, okay, electrical force, gravitational force, this force, that force, centripetal force, impulsive force is one of the forces. Okay, and usually when we talk about impact, collision, then you want to think about impulsive force. Okay, and of course, by extension, it's just a side note, when you think about impulsive force, you also must think about the time of impact. Okay, and then remember the relationship between the two. So give one reason why the egg cracked after the impact. Number 1 is the time of collision. Actually, you know what? Let's use impact. Okay, the time of impact is small. Okay, the two reasons, okay, why you will have a big a big impulsive force lah. Sorry. Uh, the main reason why you have a big impulsive force, number one, is the time of impact is very small. Okay, and then of course, a second possible reason is, since it's not mentioned here, the impulsive force is large. Okay, so two possible reasons. If I look at the question, there's no indication here about the impulsive force, so you can actually put it into the answer. Okay, one reason why the egg crack is either the time of impact is very small and the impulsive force is very large. Again, reminding us that whenever you answer questions regarding impulsive force, these two must come together. You cannot separate the two. Okay, so state one way to avoid the egg from being cracked and give a reason. Okay, this is the thing. One way is 1 mark, obviously. Okay, and then the reason is the other mark. So you want to be careful. Although it's 2 marks, you're not supposed to give 2 ways. Okay, you're supposed to give 1 way only. So there are many possible answers for this. I think when I was discussing this with the extra class group the other day, they gave all sorts of methods. Okay, and this is a good question because it's really easy to score here. Okay, just think logically. Okay, one way you can wrap the egg, okay, with bubble wrap. Yeah, bubble wrap also can lah. Okay, bubble wrap, sponge. Okay, it can also be newspaper, but lots and lots of newspaper lah. Okay, actually, you know what? Newspapers. So that is indication lah. Okay, one is to wrap the egg. Another way is, of course, to change the wooden block. Change the wooden block to a plasticine block or sponge. Okay, or I would not really, generally, I wouldn't say carpet because I feel carpet is too thin. Unless you say the thick carpet lah, then also can lah. But either way, there are many ways to answer this question, and there's no real one set answer lah. Okay, I'm just giving you the answer that I would usually write, which is wrap the egg lah. Okay, wrap the egg is the most popular. Change the wooden block to a sponge block or plasticine block. Okay, I think it's fine. But the reason for this, okay, and I think after some time you should know the reason lah. Okay, is either to increase the time of impact, okay, so that the impulsive force decreases. Okay, again, everybody, I feel that the marking scheme will probably be salah satu daripada ini. It's either to increase the time of impact or to decrease the impulsive force. Okay, I believe the marking scheme will be either one of these answers will be the answer. But generally, I like to tell my students, I feel that you should just write both. Okay, because I feel that it comes as a set and you should remember it as a set. You increase the time of impact so that the impulsive force decreases. Okay, and of course the other way around. Remember it as a set and answer it as a set. I think to overwrite something that is correct lah. Okay, you overwrite an answer, it's better than underwriting lah. Okay, if you hold yourself back, then what if the marking scheme is very strict? Okay, then you're like, okay, so you have to answer in as full as you can. Oh, that's it. Okay, let's move on to Kelantan. Okay, hold on. Okay, again, everybody, feel free to make yourself a cup of coffee or whatever it is that you drink. Okay, to keep yourself awake. Because this is just a 2B session lah. Okay, there's no break because it's so early in the morning and we want to try to finish this before 10:30, preferably not 10:30 lah. Okay. Oh, you know what? Actually, I just want to make a quick mention lah. Okay, I'm not sure whether I have done this before, but I feel that I should mention. Okay, generally in the paper 2 structure lah. Okay, question number 1 to question number 4 are what we call the knowledge questions. Okay, knowledge questions include definition, calculation, some explanation lah. okay, which is what we saw in this question just now. Very knowledge. Okay, what is the definition? What is the concept involved? Give one reason, state one way. Okay, and I think in question 3 and 4, the calculations will be more obvious lah. Okay, and then question number 5 and question number 6 will be the compare and relate question. Okay, I think in general, the paper is structured in that way lah. Okay, unless they decide to throw you a curveball this year and then mix all the questions around, I don't think it will run very far from this structure. Okay, question number 7 is the making choice question. Okay, and question number 8 is the problem solving question. Okay, problem solving means let's say for example they give you a dam and then they ask you to redesign the dam. Okay, change the height lah, this one that kind of problem solving lah. Okay, which is very similar to the section B, section C question. Okay, again everybody, when I say this is the making choice question, I'm saying that the majority part of the marks come from these questions lah. Okay, still got definition and may have what will happen, that kind of question tidak boleh lari lah. But the main bulk of the question comes from this. Okay, and then of course we have question 9 and question 10, which is the section B, the section B question 9, question 10. This is the making choice question. Okay, yang soalan 10 markah itu, okay, the making choice question, which is the similar question to question number 7. Okay, and then of course question number 11, okay, is the problem solving lah. The soalan 10 markah. Okay, sorry actually, you know what, let me making choice calculation question. Okay, manakala in question 11 is problem solving, compare and relate question. Okay, so when you look at this structure, okay, it helps to know. It helps to know the structure because I know of some students, they will attack the certain questions that they can answer first. For example, if you're very good at compare and relationship, you don't start at question 1, you immediately jump into question 5 and question 6. Buat dulu apa yang kamu boleh buat, yang compare and relate. Some people like to do that, especially when they have practiced doing the compare and relationship a lot. Okay, some people want to answer the making choice questions first, question 7 and then make choice, and then and then the problem solving. Baru diorang pergi kepada soalan yang diorang tidak suka, contohnya calculation. Yeah, I know majority people don't like calculation questions, simply because they don't have enough practice lah, I feel. Okay, and so they attack those questions last. It's just unfortunate, well, not really unfortunate lah, it's structured in that way lah. It's just that our paper is structured so that all the easier questions, okay, come first, question 1 to question 4. All the, don't need to think so much, just answer only. So calculation, explanation, definition comes in question 1 to 4. But I know of some students who, they skip the first 4 questions and they go immediately to question 5 first, because they know that, okay, question 5 is compare relationship. I can do this. Okay, and so they do that without having to, stress their heads out about the first 4 questions. They say, okay, the question yang saya susah mau jawab, nantilah saya jawab kemudian. Okay, and I think that's a good strategy. Okay, so that you tackle the questions that you know that you can do with the highest confidence. And then yang kamu tidak confident sangat kan, kamu tinggalkan yang di belakang. I think it's a good strategy. Okay, something for you to think about lah. Okay, all right, Kelantan 2023. Sorry, that's so-called short break. Okay, 9.1 shows a boy jump from a stationary trolley to get over a wall. Wow, the trolley is pushed backwards. Okay, the trolley is pushed backwards as the boy jumps. So name the type of collision shown in 9.1. Okay, remember question number 9 is section B question. It's a 10-mark question in making choice, and then there's some calculation involved. Okay, so this type of collision will be explosion. Okay, just remember there are 3 types of collisions. Number 1 is elastic, sorry. Okay, elastic collision. The second one is inelastic collision. And the third one is explosion. Okay, in The only one yang melibatkan two things together and then they split is explosion. Elastic collision, you must have two separate things and then they collide. Elastic will be they move separately after the collision. Inelastic is pada mulanya mereka separate, they collide, and then lepas itu mereka bergerak bersama-sama. That's inelastic collision. So there's only one situation which involves dua-dua sama-sama baru berpisah. Okay, and that is explosion. Okay, explain the boy's action that allowed him to avoid the risk of injury during the landing. Okay, so avoiding the risk of injury, again, everything comes to lengthening the impact time. Okay, so there is 4 marks over here. I would suggest that you give 2 actions, okay, and 2 explanations. Okay, so the general one, which will be bending the legs, okay, bend his legs during landing. Okay, and then the reason for this will be to increase time of impact and complete the answer, okay, to reduce the impulsive force. Okay, so 1 mark for the method, and then the second mark is for the reason. And then give another set of suggestions. Okay, you can use the same reason actually, but you give another set of suggestions for the action. Okay, and I can't remember what I told the extra class group the other day. Oh, I said that, oh yeah, roll over. Okay, when he lands, okay, or no, take a few steps forward. So instead of just landing, lepas dia landing kan, then they take a few steps forward to reduce the impact on his knees. Okay, so you can say run a few steps, run or walk a few steps forward okay, after landing. Of course, in gymnastics, this is not good but obviously this guy is not doing gymnastics okay. Gymnastics, different set of rules. So anyway, run a few steps forward after the landing, and you can actually reuse the same answer again to increase the time of impact, to reduce the impulsive force, or you can also say to reduce the impact on the knees. Okay, after landing. Astaga. Okay, to reduce the impact on the knees after the landing. I think that's fine. Okay. Wow, I'm actually quite... No, I just realized that there are 56 people over here today. Wow. Okay. All right, let me continue. Okay, diagram 9.2 shows the structure of a water rocket. Okay, so you have the air, water, exhaust, wings all over here. And as we anticipate, question number 9 is a making choice question. Okay, so sometimes the choice comes in a table, which is easy for us to analyze. Sometimes it's a picture, which may be a little bit difficult. Okay, for our extra class, because I've already taught you for so long, I hope that you know that when you have to answer a 10-mark question, okay, you have to answer in a table form. Okay, so I'm not going to discuss the table format here because I feel that I've talked about it so much that you should know it by now. What I'm just going to do is I'm going to give you the answer, the analysis of the table, and the reason, okay, and which you can just copy down. But just know how, make sure you know how to write the answer. Okay, it's the main thing that you should know. Okay, the mass of the rocket should be small. Okay, this is what we're going for. Okay, let's just analyze first and then we'll talk about the reasons in a little while. Okay, the rocket shape obviously should be aerodynamic. Okay, and then the volume of water. Okay, the volume of water, I know this is a number, but you should not be writing numbers. Okay, you should go for a less volume of water. Okay, and finally, your angle of launching should be 45. Now the reason why, okay, for angle of launching you have to write 45 because there's only you know, it's not really more or less. You cannot agak. It's either 45 or 90. Okay, but the reason for this, okay, let's take a look. So state the characteristics of the watermelon so that it is able to move the longest horizontal distance. Okay, just a reminder that you cannot write this as your answer for the reason. Okay, this is the most important thing. Okay, you cannot write this as your answer for the reason. You can write any other answer except that can move the longest horizontal distance. Longest horizontal distance means boleh pergi paling jauh. We are not interested in pergi paling tinggi. Okay, there are two possible questions for rocket lah. Number one is either you want it to travel higher, okay, which is a vertical distance, or you want it to travel further, which is a horizontal distance. Okay, I don't think it is likely that they will ask you to be higher and further lah. Okay, because I don't think it's enough for 10 marks lah. Okay, so either ask you for higher, or actually I feel that they will ask you in this kind of case, they will ask you for further situation. Okay, so the reason, okay, so as a reminder, okay, when you are writing the reason, okay, bila kamu tulis itu sebab for the characteristic, make sure that your answer has a physics concept inside. Okay, I cannot stress this enough. So we are no longer looking for answers that are so general, like even a 5-year-old also can give you that kind of answers. We're not looking for that kind of answers. So this is probably the biggest challenge now, okay? Because sometimes the black book, I know, the black book, they give the answer, but some of the answers are pretty general, okay? And so I recently found out from, you know, a couple of friends that now they have been teaching their students to write their explanation and to make sure that their explanation, in as much as they can, to write physics concepts inside. Okay, so for example, last time we used to say that, oh, okay, if the mass of the rocket is small, then the answer for the explanation is so that it is lighter. Okay, so we don't want that kind of word lighter. Lighter is not a physics concept. Okay, so what if it is lighter? If it is lighter, then what happens is you can achieve a big acceleration. Okay, you can achieve a high acceleration. So acceleration is a physics concept. So you want to make sure that your answer for the reason has a physics concept inside, so that it sounds it sounds sophisticated. It sounds like a science student actually wrote this lah. Okay, I know black book will say, oh, small mass means lighter, but I would actually advise you to try to think of physics concepts answers, and train yourself to think in that way. Okay, it's not too late. Okay, we can still do this one. Okay, aerodynamic, I think the standard answer is quite good. Okay, aerodynamic, the answer will be to reduce air resistance. Okay, and actually, aerodynamic to reduce air resistance, by extension, you can also say high acceleration or high resultant force. What am I doing? Sorry, high resultant force. All of which, okay, air resistance, acceleration, resultant force, all of which are physics concepts. Okay, so you can put it in that way lah. Our standard answer from the black book, aerodynamic, is usually reduce air resistance. Totally fine. Okay, because it is a physics concept. Okay, the volume of the water should be less. Okay, and there are a couple of answers for this lah. Okay, when you have less water, inside, I know you want it to travel further, and you think that, oh, if you put a lot of water, then it has enough impetus to go forward lah. But if you think about it, in this case, okay, the air rockets generally actually function more on the air pressure inside. Okay, not so much on the water lah. Yes, the water provides a little bit of fuel, but it is the air pressure that accumulates is what causes it to go very fast. So two possible answers, go very far. Number one is high air pressure. Okay, because you have more air than water. If you have a half-half situation, that means half air, half water, there'll be less air pressure, of course. You'll be all, the fuel has taken up the space for the air. Okay, and by extension, if you have a high air pressure, you also will have high acceleration. Okay, and if you have high acceleration, means you should be able to go further. Okay, that train of thought. Okay, the angle of launching, okay, is 45 degrees. Okay, and this is the problem, because you know that if you are setting your rocket at 45-degree angle, dia boleh pergi jauh. For example, like merejam lembing lah, when you a javelin throw, nobody throws at 90 degrees ke atas lah. You want it to go as far as possible, and I think generally, people agree that by throwing it at a 45-degree angle, you give yourself the best shot for throwing the javelin the furthest lah. Many other factors, but one of the factors is of course the angle on which you throw the javelin. Okay, the problem is this: we cannot use this answer to achieve the longest horizontal distance because it is already in the question. Okay, so how do you write this answer without talking about the horizontal distance? Okay, so one alternative would be to produce a bigger horizontal force. Okay, to produce a bigger horizontal force, which will produce a bigger horizontal distance. Okay, the most important thing is you cannot use the word horizontal distance because it's already in the question. Okay, so and this is the challenge. Macam mana saya mau menjawab supaya dia tidak ikut jawapan di dalam soalan. You should not be writing can travel further. I know this is I mean, it's the same thing lah, kan? Able to move at the longest horizontal distance. It's the same meaning as traveling further. Okay, so instead of writing traveling further, what is the physics concept there? Okay, talk about the can travel further. Yeah lah, longest horizontal distance lah. Okay, sorry, I'm talking in the situation where, let's say they don't give this condition lah. Okay, so instead of writing can travel further, right? Can produce a longer horizontal distance. Okay, we cannot use this in this question. I'm just saying that instead of writing can travel further, okay, use the words longer horizontal distance, because that's the answer with the physics concept. Okay, so this is what we are working towards lah. Okay, we are working towards giving more quality answers, okay, that have physics concepts in them. Okay, and trying to move away from the simpler answers like lighter, can travel further, which I heard from a couple of friends that actually is not accepted anymore lah. Okay, so we need to be careful about this. Doesn't more problem correct, but if there's not enough pressure, I think it's a combination of both lah. Okay, like if you don't have enough pressure, then like in a car lah. Okay, sorry, this question came. Doesn't more water produce more backward momentum for thrust? Which is true. It is true if you think about it lah. But the main point, sorry, the main principle behind the water rocket actually comes from the air pressure. You need to produce enough air pressure, okay, so that you can push the water out lah. If the air pressure is not strong enough to push the water out, even if you have a lot of water, so it's just going to trickle out. It's kind of like, what if you put a lot of petrol into an engine that is useless? The car cannot move faster. The point behind the car moving faster and better is not so much on the petrol that you provide. It's not on the fuel that you provide, but balance as everything should be. Yeah. I don't think in this case it's not an either or. How does a rocket move horizontally? Well, when you talk about horizontal distance, okay, fine. I like these questions. Sorry, it gives us a break. What am I drawing now? Okay. So when sorry, when you launch a rocket, the rocket moves this way lah, kan? Okay, it moves like that and it comes down. Okay, I'm sure Nathaniel Santana, you can tell me what is this concept. Okay, but when we calculate when we talk about the horizontal distance, okay, we're looking at this component. Okay, when a rocket is, what is this? What is this movement called already? This one. When the rocket is in a trajectory, doesn't it fly upwards? It flies upwards if you set your rocket like this. Okay, if you set your rocket like this, then it will fly upwards lah. But if you set it at a 45-degree angle, kind of like this, okay, this is a 45-degree angle, then it will move upwards and forwards. Okay, so there's a x-axis movement and there's a y-axis movement at the same time lah. Okay, so it goes upwards and forwards. Okay, and so the question is, you don't want it to be totally 0 degrees on the ground like that. Okay, you don't want your rocket to be like that, because it doesn't make sense lah. Okay, so you need to set it at a certain angle, like this kind of angle. Okay, preferably at a 45-degree angle, so that it can move upwards and forwards at the same time. But what we are interested in is the forwards component. Okay, you cannot set it like this on the ground, because if it goes forward, it's going to go against a lot of friction with the grass and whatever lah. And the moment you set it even at 1 degree, it's going to move upwards and forwards. You cannot really run away from that fact. Okay, so if you set it at 90 degrees like this, okay, then obviously it's only going to move upwards, because you're not giving it a chance to move forwards lah. Okay, so in this question, I like the way the question is structured, so that it is able to move at the longest horizontal distance, telling us that it's not interested in how high it goes. Okay, it just wants to know when it is traveling upwards and forwards, how far can it go? Okay, kind of like the javelin throw also lah. So if the question doesn't, the next question. So if the question doesn't ask for the longest horizontal question, will the choices still be the same? That's a very good question. If the question doesn't ask for longest horizontal, means the only other possibility is the longest vertical. Right. If it is longest vertical, okay, this is a question that the extra class group also asked. Okay, if it is a longest vertical, means travel upwards okay, the highest. Okay, or there was 1 year, I think they asked in a trial question, can reach the top floor of the school building, okay, which is 4 stories high, like Wisma All Saints lah. Okay, you want to find a rocket that can reach the roof of Wisma All Saints. Then you will want to use a 90-degree angle, because you're not interested in the furthest. Okay, yeah, so you want to use a 90-degree angle. The answer for the mass will be the same. Answer for the rocket shape will be the same, aerodynamic. The answer for the volume of water, I think, should be the same also, because of the air pressure. But the angle of launching is where it will be different. Should be 90 degrees. Okay, yes, thank you. Projectile motion. Yes, that's what I was. Projectile motion. Okay, the one that goes upwards and forwards. Okay, so but this question, which I feel that is the more popular, physics SPM question would be about the longest horizontal distance. You want to travel further. Okay, so last year when I did this with the Form 5 groups, they were actually looking to travel as far as they could, and so they tried to angle the rocket at different angles, and it's a combination of a lot of factors okay. There's no one factor that that determines the entire thing even if, let's say for example, even if you have the best looking rocket the correct angle but if your mass is very heavy, you can't travel that far. Okay, which goes to show that, as in all things, as in life, okay, we are the sum of the things that are around us okay, everything that happens to us is the sum of all the factors that are surrounding us. There's no one single decision that determines our entire life, or there's no one single result that determines our entire life If one single result from the SPM determines your future and your entire life, it's kind of scary okay. there are a lot of other factors that go into our success. SPM is just one of them. Okay. Not saying that SPM is not important. Okay. I'm saying that SPM is important, but it's just one of the many, many factors in your life that determine your success. Okay. Anyway, before I lose the interest of the other 54 people, okay, by answering these two people. Thanks for your questions. Let's move on. Okay, we still have a calculation question to go. Okay, just to bear in mind, question number 9, definition, explanation, making a choice. Question number 9 or question number 10. And finally, there's a calculation question. Definitely got calculation question involved. Okay, so calculate the momentum of the bullet after the gun is fired. Okay, remember that before explosion, okay, the total momentum is 0. Okay, after explosion, okay, the recoil velocity, I'm going to call it V, mass is 200 grams. At this point, change it, or yeah, you should change it, okay, to 0.2 kilograms. So this momentum over here will be 0.2 V, negative because it is going behind. Okay, and then this one will be the mass over here is 0.002, I think. 1, 2, 3. Yeah. Okay. Oh, sorry, 0.0. 1, 2, 3. 0.02 kilograms. The velocity is 100. So the momentum, okay, the momentum will be 0.02 times 100, which is 2 kilograms meters per second. Okay, so the total momentum will be 2 minus 0.2 V. Okay, so in order to calculate the momentum of the bullet after the gun is fired, okay, the momentum of the bullet, okay, which is here, okay, which you already calculated. So let me give you the answer for this. Oh, sorry, here. Okay, 2 kilogram meters per second. And the reason why I have to change it is because the question said, state your answer in SI unit. So I have to change my mass to kilograms. Okay, dual kilogram change to kilogram will be 0.02 kilograms times 100, because momentum is mass times velocity. Okay, which will give you 2 kilograms meters per second. Calculate the recoil velocity of the gun. Okay, so before explosion equals to after explosion. So 0 equals to 2 minus 0.2 V. Okay, and when you do this, you get V equals to 10 meters per second. Okay, 2 divided by 0.2, totally not a problem. Okay, but just to remind you, since the velocity is going to the left, you need to write negative. Okay, negative 10 meters per second, because the velocity is going to the left. Okay. Right, let's continue. Okay, we're going to Melaka next. Melaka, not Malacca. Melaka. Hold on. Okay. This is the section C question. Okay, so section C question, as I mentioned before, okay, we are looking at problem solving. Okay, compare and relate question is there. Okay, but the main part of the question, the 10-mark question, is the problem solving question. Okay, Melaka. Okay, 11.1 shows the athlete. Okay, high jump athlete before landing. Okay, P and Q. Obviously, the difference is in the mattress lah. Okay, so what is meant by force is a standard definition. Force is a push or pull. Okay, that's it. Sounds a bit weird, but yeah. Okay, by using diagram 11.1, 11.2, compare the thickness of the mattress. Okay, number 1. Number 2, the athlete's impact time. Number 3, the athlete's impulsive force. Okay, we seem to be moving in this direction this year. Balik impulsive force, impulsive force, impulsive force. Okay, thickness of the mattress, 11.1 is less than 11.2. Okay, can be seen here. The impact time, since this is a thinner mattress, so obviously the impact time will be less lah. 11.1 is also less than 11.2. Okay, and impact time impulsive force is seperti dacing. Okay, one higher, one lower, so this will be 11.1 is bigger than 11.2. Okay, relate the athlete's impact time and the athlete's impulsive force. Okay, athlete's impact time, athlete's impulsive force. The bigger the impact time, the smaller the impulsive force. Okay, atau yang terbalik. And then the final mark, which is the fifth mark, is name the law involved. Okay, the name of the law is Newton's third law of motion. Okay, Newton's third law of motion. Okay, if the physics concept involved, if the question says name the physics concept involved, then the physics concept will be, impulsive force but in this case it's a law. Okay, the first law has to do with inertia. The second law has to do with acceleration, force and acceleration, or mass and acceleration. And the third law is the impulsive force law. Not really impulsive force law. Every action has an equal and opposite reaction. That's the third law. Okay, and since we're talking about the action, that involves collision. Okay, equal opposite reaction means bila kamu kenakan force, the impulsive force comes back onto you. So in this case, the third law of motion is in play here. All right, long jump is a track and field sport that involves a horizontal jump over a long distance. Now, Zara, this is your answer. Okay, traveling further, but you still have to travel up. Okay, it's a balance of both things. It's not just one single determinant factor. Okay, state the reason for the athlete to bend his knees while landing. Okay, so this is a 3-mark question. Okay, so if it's a 3-mark question, then you kind of know 2 marks has to go into increase the impact time. Okay, so the first mark will be to increase impact time. Okay, the second mark will be to decrease impulsive force. Okay, and so the question will be, why is there a third answer? Why is there a third mark over here? Okay, so I would think okay, the third mark will be to prevent or to reduce injury okay on the athlete. I wouldn't give 3 marks for this but anyway, this is how the question is structured. So sometimes you just have to figure out where the third mark comes from okay, just simply again overwriting. Okay, it's always a good idea. Okay, state the force acting on the athlete when he's in the air. There's only one other force over here, which is gravitational force. Okay. Interestingly, I think you can also write air resistance. Okay, because it's in the air. Okay, air resistance, air drag, all these are forces okay, but in the air okay, so remember to include the words air resistance. Okay. Pole vaulting is an athletics event whereby a person uses a long pole as an aid to jump over a park. Okay, so you want it to be here like this. So by applying the physics concepts learned, suggest suitable equipment and techniques, etc., etc. This one is to achieve better performance. Yes, there's no physics concept involved in this answer, so you can actually, use whatever answer that, not like the horizontal distance just now. Okay, thing is this, this is a 10-mark question with only 1, 2, 3, 4. Okay, so you will have to double one of the characteristics. Okay, you can either do 2 answers for the clothing, which is a bit weird I feel. I think that you should do 2 answers for the safety. Okay, 2 answers for the safety. Oh, actually, you know what? I think the better answer would be two answers for the pole use, because you can talk more about the pole. Yeah, talk about the pole more lah. Okay, I think that's a better answer. Okay, so for the pole use, one will be very elastic lah, or high elasticity, sorry. High elasticity. Okay, and the reason for this, I'm going to write the reason in blue. Okay, easy to bend. Okay, high elasticity so that you can bend it easily. Like if it's very, very keras, it's not very good. Okay, high elasticity so that it is easy to bend. A second possible answer, okay, would be smaller mass. Oh, you know what? Let's use the word lighter. Okay. Yeah. Okay. Lighter lah. Lighter or smaller mass, same answer lah. Okay. You want a pole that is lighter or smaller mass. Okay, so that it is easy to carry. But not to say easy to carry lah. I think that because we want to go for answers that have to do with physics, okay, rather than just, like, oh, any 5-year-old also can answer this kind of question. Okay, lighter and smaller mass, so you can write doesn't require lah. Okay, much force to lift. You have to greater acceleration. Problem is the pole is so long and there's not really that much drag on it. I guess you can write. Yeah. Yeah, easy to bend is not a physics concept, but I really cannot think about high elasticity. I guess high elasticity will also be smaller spring constant, but we're not talking about smaller spring constant in this case. Flexible, easy to bend. Yeah, high flexibility. I think that's a good answer. Thank you. High flexibility. Sorry. Okay, high flexibility. I think flexibility is a physics concept lah. Store more elastic potential energy if it bends more. If it bends more, store more elastic potential energy. Yeah, I think that's possible. Oh no. Okay, hold on. Yeah, I think that's a possible this one. Gonna skip what? Hey, okay, I need to screenshot my this. Increase elastic potential. Oh yeah, okay, fine. I'm acknowledging you now, Amita. Okay, and this is gonna go into the recording, so congratulations. Okay. Public apology. Yeah, it's okay lah. It's not the first time. Lighter mass doesn't require much force to this one. Okay, our standard black book answers lah. Okay, since we are highly using the black book, well, sort of. Okay, of course you want to use a strong pole lah. Okay, a pole that is made of strong material. Okay, and I've been thinking about this for some time lah. When I was preparing for this class, I was like, how do you relate? How do you put a physics concept on when you're talking about strong material? Strong material, generally the answer is doesn't break easily lah. Okay, strong material doesn't break easily. So I guess if you really want to put a physics concept inside lah, okay, if you cannot remember this, I tell you, okay, don't skip it lah. Okay, just write whatever answer and then pray very hard that your answer be accepted. Okay, strong material doesn't break easily. That's the standard answer that we've been using. But if you really want to remember, if you can, okay, I guess you can write strong material and then this one, you can say it requires a lot of force, okay, to break it. Because force it's a physics concept lah. Basically, you're just saying doesn't break easily. That's all you want to say. Strong material so that it doesn't break easily. Long lasting. Yeah, long lasting is also the same concept. So that's why when I was thinking about this answer, I was like, yeah, mau ajar ka ini strong material. I feel like I should teach lah. Because even in the marking scheme, strong material, it says withstand the mass of the athlete. Withstand the mass of the athlete. Now, I would say withstand the weight of the athlete. I think it's a better answer. Thanks, Sam. Okay, I need to check whether I'm skipping anybody in case some people, need another public apology. But I was thinking doesn't break easily. How do you write it so that it sounds, sophisticated lah? If you can remember, then good. If you can't remember, don't skip it. Okay, just write doesn't break easily and hope that the marking scheme would not be so tight on this lah. Okay, so this really depends on on the people that are marking this one. Okay, if they decide that we should be stricter this year because the questions are easier, then you need to prepare for that lah. Okay, so we need to be as prepared as we can. But yeah, I think your answer withstand the weight of the athlete lah, rather than the mass, because force and weight are weight is in newtons, force is also newtons. So I think to say withstand the weight of the athlete is a better answer than withstand the mass of the athlete. Okay. Anyway, I've given 3 possible answers: high elasticity, lighter, strong material, but you only actually need 2, because remember, this is a 10-mark question. Okay, this is a 10-mark question. You need to make sure that you have 5 characteristics out of the 4 the things that they've given to you lah. Okay. Can you write more than 5? Yes, you can write more than 5. You should write more than 5 actually. Okay, 2.5 hours is a very long time. Just write as much as you can. Apa yang boleh diterima akan diterima. Whatever that is wrong, you won't be penalized for it. Okay, so don't worry so much. Unless the pasangan salah lah, then no choice lah. Okay, the movement of the athlete movement is very easy. Of course, the athlete has to run lah, kan? But don't just say that the athlete must run. Okay, run with high, I would say velocity. Yeah. Okay, high velocity. And then the reason, this is standard. Okay, run with high velocity to increase kinetic energy. Okay, run with high acceleration. Well, I don't think it's that easy to achieve high acceleration if you're running, but can lah. Increase momentum. Increase momentum. Because I feel that this guy is running, he has accumulated kinetic energy, which transfers into elastic potential energy and brings it all the way to the top. I think you should write energy instead of momentum. I feel that the momentum answer is a little bit irrelevant. It's not wrong lah. Okay, just I'm questioning the relevance lah. Okay, boleh atau tidak lah. Okay, the athlete's clothing, I think this is standard. Okay, oh sorry. The athlete's clothing should be light and tight. Okay, standard answers lah, light and tight, tight and light. Okay, and the reason for this will be to reduce air resistance. Okay, this standard blackboard answer, I don't think you need to talk about the material because it's not asking for the material. But if you want, I guess you can. But make sure that the material is still follows within the light and tight answer lah. Okay, so like nylon, don't say cotton lah or silk. I don't think I've seen an athlete wearing silk before. Okay, safety of the athlete. If you take from our question just now, the mattress question over here. So you want to have safety of the athlete. I think 2 possible answers for this. Okay, number 1. Oh, sorry. Actually, there's only 1 possible answer because he's not going to land on his feet. Safety of the athlete is to increase lah. Okay, increase the number of mattresses. Or you can also say use a thick and soft mattress. Okay, and the reason for this is the standard answer. Okay, increase the time of impact okay, or to reduce the impulsive force. Okay, increase the number of mattresses. Yeah, we can't really say bend the knees, although let me see. Sorry, I have very little experience with pole vaulting lah. But generally, when pole vaulters fall, they like to fall lying down. I don't think they fall like this, like yeah, talk like that lah. I don't think they fall. But I guess if you want, they can lah. But I think the determining factor, since it's such a high height, the biggest determining factor I think should be the mattress lah. Okay, increase the number of mattress, use a thick and soft mattress lah. I think that's a better answer. Okay, for this. All right, let's move on. So again, everybody, remember this question number 11. Okay, there's no table, there's nothing for you to compare, but in this question, you need to be aware that it is a 10-mark question. Your table must have 5, okay, at least 5 things written on it. Okay, walaupun dalam soalan dia hanya bagi 4, so some things you will have to double up, okay, to make sure that you have 5 things. But actually, if you look at how many things I've given to you, 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 possible answers, and I think it's totally fine. Okay, let's move on to Negeri Sembilan. Negeri Sembilan. Where is Negeri Sembilan? Okay. Okay, follow through action, okay, in a discus throw sport. What is meant by impulse? Impulse is the product. Oh, no, sorry. Product is momentum. Impulse is a change in momentum. Okay. As a side note impulsive force, okay, is the rate of change in momentum. Okay, very, very small difference between the two. One is the rate of, because it's impulsive force, and one is just a change in momentum. Okay. Now, by applying a suitable physics concept, explain how the follow-through concept, okay, can increase the impulse acting on the discus. Okay, so point number 1, for the follow-through action, okay, follow-through action increases the contact time between, what is this two? Oh, the discus. Okay, the discus and the athlete. Okay, increase the contact time is the first point. Second point, when the contact time increase, okay, impulse increases. Okay, because impulse is equals to follow through, no, force times time. Okay, force times time. Remember that impulse got 2 formulas now. Okay, impulse is either the force times time or is the change in momentum, mv minus mu. So if your time increases, then your impulse increases. Okay, point number 3, because the impulse increases, the change in momentum also increases. Okay, and finally, this results in a higher final velocity, okay, on the discus. Isn't 2 and 3 the same? Yes and no. Both are talking about impulse. Okay, but point number 2 is talking about impulse in terms of the force and the time. So the point number 1 is increase the contact time, so you increase the impulse. If the impulse increase, the change in momentum increase. The problem is not really a problem now. Okay, our understanding of impulse is we tend to put the two together as one formula. Ft equals to mv minus mu. And this is the formula that they give in the formula list. Okay, but I've mentioned before, and I think it should be mentioned again, that when you talk about impulse, I think you should think of it in two separate formulas. Impulse is either force times time, okay, or the change in momentum, mv minus mu. Okay, but the formula over here exists to tell us that if the time increases, then the change in momentum also increase. Okay, so it is, yes, I guess you can say that it is the same, but there is a slightly different connotation to it, because point number 2 is related to point number 1, and point number 3 is more related to point number 4. You are separating the FT and the MV minus MU so that you can get the 4 points lah. Okay, die also you need to have at least 4 sentences. Okay, or or yeah, 4 sentences, 4 short sentences, or 1 very long sentence which is all 4 points in it lah. Okay, so but breaking it up into 4 points or 4 sentences, kind of helps you to structure your answer so that okay, I need to have at least 4 points. Think as hard as you can, okay, on how to get the 4 points. So I wouldn't say that it's not the same. It is the same actually, but there's a slightly different relation to it. Second point is more related to the first. The third point is actually more related to the fourth, talking about the momentum and the final velocity itself. All right, let's move on. Metal ball of mass. What question number is this? Oh, this is section B. Okay, or calculation. Okay, mass of 500 grams. Immediately change this to kilograms. Okay, 0.5 kilograms. 10 meters. Okay, we're at the good this one. The weight of the ball, okay, is W equals to M times G. So 0.5 times 9.81. So give you 49.05 newtons. Okay, weight now 49.05 newtons. Okay, the velocity of the metal ball just before it reaches the ground. Okay, hold on now, let me this one. The ball over here is going here. This is 10 meters. Okay, so if the ball is released, okay, there's one important piece of information. U equals to 0. Okay, and since this ball is going down with an acceleration of 9.81 meters per second squared, we want to find the velocity, which is V. Okay, and this is the letter S. So you kind of know that you have to use the formula V squared equals to U squared plus 2AS. Okay, the kinematic equations lah. Okay, and when you calculate this, you get V equals to 14.007 meters per second. Okay, can't really run away from this formula. I feel that in the physics paper, they will ask this at least once, especially since this is one of our focus topics for this year. So it'd be a good idea to refresh on the calculation questions. Yes, which reminds me, I need to give the answer for the calculation question. This one. Yes, Miss Tan. 1, 2, 3. Oh yes. Thank you very much. 4.905 newtons. Yeah. 0.5. Sorry, my bad. Okay, the impulsive force acting on the metal ball if the time of impact is 0.5 seconds. So this is F equals to mv minus mu over t. Okay, if you got the V from there, okay, you will get 0.5 times 14.007 minus 0.5 times 0 over 0.5. Okay, this is from the B answer lah. The 14.007 is the answer from the V. Sorry, answer from the Roman number 2. Okay, and you should get the answer 14.007 newtons. Okay, for this. Okay, let me talk about this question. Okay, since we are already on this topic, I want to say lah. Okay, let's say your answer for number 2 lah. By some funny calculation, you got the wrong answer somehow. Okay, the V, you somehow got the wrong answer, and then you proceeded to use the wrong answer in this thing over here. Okay, you proceeded to use the wrong answer in this particular answer over here. You will still be able to get 1 mark over here for the correct substitution, even if it is the wrong answer. It's just that you will not get the mark over here lah. This one memang tidak boleh dapat sebab jawapan sudah salah. Okay, so as I mentioned before, it is not a total loss. Okay, it is not, kalau soalan nombor 2 saya salahkan, soalan nombor 3 terus, kalau saya salah ni semua salah. No lah, it's not a total loss. You can still get at least 1 mark just by substituting it. Okay, you cannot get the full mark, but at least 1 is better than 0. Okay, they cannot penalize you twice. Sudahlah kau dapat jawapan salah, lepas tu kau guna jawapan salah lagi dalam nombor 3. Cannot lah. The idea is there, that you're substituting that velocity into the formula. So 1 mark is for the idea, the working. Okay, you cannot get the mark for the final answer, but at least it's not the total loss. Okay, so which is why 2 pieces of advice lah. Number 1, when you're done with the paper, always check your calculation questions to make sure that you didn't make a mistake in the calculation. Okay, that's why it's 2.5 hours. It's a very long time. You can answer all 3 essay questions. You can double check your calculations just to make sure that you didn't make a mistake. Okay, and then my second piece of advice is don't panic. If you got the wrong answer, it is not the end of the world. Okay, it's not the end of the world. It's not the end of your physics grade. Okay, you just at most, be just penalized 2 out of 4 marks. Okay, you cannot get a full mark, but you will not get a 0. D, diagram 9.2 shows a cricket player. You are required to study the characteristics of the batting equipment. Oh, I know this question. This is a question that came up in certain discussions and it was very highly debated. Okay, mass of the bat. Okay, mass of the bat, material of the helmet, shoe soles, and the thickness of the leg pad. Okay, this is a, let me talk about the mass of the bat in a little while. Okay, material of the helmet. Okay, material of the helmet, I think is quite, this one, we definitely have to use carbon fiber. Okay, the soles of the shoes will be with spike. Okay, and then the thickness of the leg pad will be, of course, you want a thick one lah. Okay, just from this analysis alone, it's very obvious that we're going towards W. The only problem now is W has a bigger mass of the bat compared to X and Y. Our first instinct is to go for a small mass. Where small mass means lighter means, blah, 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 blah. Okay, but when we do the analysis of the other 3, okay, you find that the other 3 are pointing towards W. And so this is always a big problem, okay, because we're so used to, mass of the bat must be very small, mass of the bat must be very small, so it's lighter. Lighter means easy to carry and, blah, 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 blah. But if you have been following the discussion, okay, on impulse, you notice that impulse is determinant on 2 factors. Number 1 is the time, okay, the time of impact, and then number 2 is the change in momentum itself. A bigger velocity results in a bigger change in momentum, mv minus mu. But not only that, a bigger mass also results in a bigger change in momentum. Okay, it's again combination of 2 things, not just one determinant factor. It's a combination of 2 things. Okay, the final velocity and of course the mass itself. Because when you have a bigger mass, okay, you have a bigger, you are going to have a bigger momentum. Bigger momentum results in a bigger change in momentum, or bigger change in momentum. Okay, is it hard to carry? Yes, comparatively, yes, it will be hard to carry than a smaller mass. Okay, but again, please don't think in 2 extremes. Okay, wow, small mass means like straw like that, very, very, very ringan. And then the big mass is like the weight of a car. So difficult. It's not that loud. Okay, we're talking about high mass, low mass. If you ask me to choose between like bowling ball, when you want to throw a bowling ball, the difference between 10 and 11, the number 10 ball and number 11 ball is not really that big, but it is a difference. Okay, it is a difference. The number 10 ball is a smaller mass, the number 11 ball is a bigger mass. Okay, but it is not like wow. Okay, it's not like number 6 and number 13 kind of ball, I think when you're talking about this one, 1.5 and 1.0, come on lah, it's only 500 grams. Okay, don't tell me don't tell me this cricket player who's been training for cricket his entire life cannot handle a difference of 500 grams. Okay, so we also have to think a little bit logically in this sense lah. Okay, I would go for a higher mass. Okay, simply because my other analysis of the other 3 items tells me that I'm going for the answer of W. Okay, so higher mass, okay, would be bigger change in momentum. Okay, because this is the discussion that has been going on in this question so far. Bigger change in momentum, bigger impulse. Okay, I think it's also a good answer because our topic in this subtopic here is bigger impulsive force. Yes, can also. Assuming I'll short this one. Teacher, what if I say more kinetic energy? Mass, yeah, also can. I think it's not a problem. But the reason why I say bigger change in momentum or bigger impulse is because our entire discussion on this question so far has been about impulse. So I kind of want to keep for lack of better word, I want to keep the momentum of the discussion, okay, to impulse. But bigger kinetic energy is not wrong. Okay, it's a good answer also actually. But it's not wrong. Okay, material of the helmet, carbon fiber. Okay, so carbon fiber, sorry, the answer that I wouldn't accept okay, for sure I wouldn't accept this answer is to protect the head of the cricket player better. Ini memang tidak boleh. Okay, because nama pun, bahan pelindung kepala. It's already obvious that you're using the helmet to protect the sun. And plus, on top of that, there's no physics concept over there. Okay, generally carbon fiber, okay, has a lesser mass, lighter. Okay, lighter or long lasting okay, or not broken easily. I guess if you want to put this one, requires more force. Okay, requires more force to break it. Okay, our new standard answer for long lasting is requires more force to break it. Okay, carbon fiber. Okay, with okay, with spike. Okay, this one is a standard answer. Okay, better grip lah. Better grip. Okay, or to prevent slipping. Okay, mengelakkan daripada tergelincir. Yes, I know. I can hear some people, isn't this answer that got no physics concepts? Yeah, I know. But I've been trying to think about how am I going to say better grip by using physics concepts. And after a long while, until I fell asleep, I couldn't figure out what the answer was. So I'm just going to stick with better grip. More friction. More friction. Yeah, okay. I think that's a possible. Yeah, that's a good one. More friction. Thank you. More friction, better grip. I feel like more friction, better grip. Can lah. You know what? Actually, if all else fails, just write all 3 lah. Better grip, prevent slipping, more friction. Okay, I don't think it's as long as the idea is there. Okay, the thickness of the leg pad is thick, and we kind of know after a long while. Okay, you want a thick one. You want a thick brake pad. Okay, is bigger. Sorry, bigger time of impact, smaller impulsive force lah. Okay, to reduce the impulsive force. Okay, or to increase the impact time. Okay, either one of these is fine. Okay, and then again, everybody, please don't forget the 9th and the 10th mark, okay, which I've been harping on since last year. Okay, make sure that you write the 9th and the 10th mark so that you complete your answer. Okay, let's move on. I know that our last question is SMKA, right? Yeah. Oh, wow. It feels like we have such a long way to go. Okay, never mind. Number one. Okay, question number one, remember, it's a knowledge question. There may or may not be calculation, but definitely it's more knowledge based. Okay, this is Pahang. Okay, what is meant by momentum? At this point, we've answered this many times. It's a product of mass and velocity. Okay, the SI unit for momentum. So again, these are all knowledge lah. It's either kamu tahu atau tidak tahu, but I hope you should know this. Okay, kilogram meters per second. Okay, what will happen to the air? Sorry, air is pumped into the water rocket. Okay, I think this answers Zara's question. This is a rocket that is going to go up. It's not going to go forward because there's no 45-degree angle. Okay, so what will happen to the water rocket when the trigger is pulled? Okay, the water rocket will move upwards. Okay, state the physics concept. This will be the principle. Yeah, principle of conservation of momentum. Okay, just to note I know that our standard answer for what will happen is increase, decrease, or remain unchanged. Okay, our standard answer for this But in this case, we can't really say what will happen to the water rocket. The water rocket will increase. Okay, so although we have a standard answer, please make sure that you bear in mind what is the question asking first okay, before you go into automatic mode. Okay, let's move on. We're going to, what is this? Penang. Okay, Penang. Okay, question number 2, also part of the first 4 questions, calculation involved over here. Okay, when traveling along the road at the velocity of 25 meters per second, the driver suddenly sees the road ahead blocked by a fallen tree and then press the brakes to stop. Okay, over here is 50 meters away. Car to stop means V equals to 0. Okay, remember just now, the ball was released, right? Okay, the ball was released is U equals to 0 because kamu start daripada kosong. When the car is stopping, you are ending at 0. Okay, so V equals to 0. So small differences like this. Okay, so U is 25. Okay, and then the time is T. This 50 meters will be S. You kind of know when I'm writing this, I hope that you know, okay, that we're heading towards this direction where, okay, saya kena guna itu formula. Okay, and then you rujuk the formula in front. Okay, velocity is a derived quantity. No need to think about this. Base quantities, there are only 7. Okay, of which velocity is not one of them. Okay, calculate the distance traveled by the car by calculating the area under the graph. Oh, what a kind question. The question already asks you to calculate the area under the graph. Okay, the area, if you notice, is a triangle. So 1/2. Okay, distance is 1/2 times, what is the base? 5, and the height is 25. Okay, so the answer is 62.5 meters. Okay. Based on your calculation in 2B1, will the car hit the following tree? The distance before it stops is 62.5, but the tree is only 50 meters away. Okay, so answer will be yes. Okay, will the car hit the fallen tree? Yes. And then give your reason. Okay, the distance traveled by the car okay, which is 62.5 meters, is greater than 50 meters. The tree is 50 meters away. So actually, technically, this is a very funny question. Technically, the car won't even reach 62.5 meters. Okay, but I guess that's a projection. All right, let's move on. Sekolah berasrama penuh. This is question number 9. So it's going to take us some time to do this. Okay, rugby player runs at a velocity of 9, pursuing the opposing team's player, which is running a velocity of 5.5 in the same direction. Okay, once player A catches player R, they both move together. This tells us that this is an inelastic collision. Okay, the masses of player A and R are 85 and 98 kilograms respectively. What is meant by 5.5 meters per second? Wow. This is a very interesting, this is velocity lah, but you're not supposed to say that it's velocity. Okay, 5.5 meters per second means the displacement. Okay, the displacement of the object in 1 second is 5.5 meters. That's what this means. Means dalam satu saat dia bergerak 5.5 meter. That's what meters per second means. Okay, oh, this is a good question. What is meant by 5.5? Interesting. The displacement of the object in 1 second is 5.5 meters. Okay, calculate the common velocity. Displacement per second is 5.5 meters. Can, not a problem. Okay, since this is a momentum question, let's put everything into perspective. I'm going to put R as blue. Okay, R is 98 kilograms, moving at 5.5 meters per second. Okay, so the momentum over here, let me take out my calculator first. 98 times 5.5 is 539 kilograms meters per second. Okay, the guy in green is A lah. A is 85 kilograms and traveling at 9 meters per second. Okay, so 85 times 9. 765 kilograms meters per second. Since they move together, okay, fine. So calculate the common velocity. So before the total momentum before. Okay, total momentum before is 539 plus 765. Okay, which is 1304. Okay, total after. Since they're moving together, it will be M1 plus M2 times V. So it'll be 85 plus 98 V 183V. Okay, so principle of conservation of momentum tells us that 1304 must be equal to 183V. So 1304 equals to 183V, which will give us V equals to 7.126 meters per second. Let me just check now. Yeah, 7.126 meters per second. Okay, calculate the change of momentum. Okay, change of momentum. It will be change of momentum of R. Oh, okay. Change of momentum is MV minus MU. Okay, for R, okay, R his mass is 98. Okay, so it'll be 98 times 7.126 minus 98 times, what was his original? 5.5. Okay, you get the answer 159.29. Yes, okay, 159.29 Newton second, or kilogram meters per second. You know what? Let's keep it kilogram meters per second. For the player of A, since A is 85 kilograms, okay, so it'll be 85 times 7.126 minus 85 times 9, because originally he was faster. Okay, 9. 159.348. That means this one is negative 159.29. Yeah, kilogram meters per second. Okay, yeah lah. Because R goes slower, so the change in momentum is, and A is faster. So, sorry, R goes faster. Sorry, R goes faster, so its change in momentum is positive, and A is slower, so change in momentum is negative. Okay, a large mass player with a low height has an advantage in rugby. Okay, I guess over here in Sabah kita panggil ni yang pindik tagap lah kan, a big mass tapi pindik. Okay, so why is this? This is in no way discriminating against the shorter people with bigger mass. Okay, ada kebaikan kalau kamu pindik tegak. Okay, I have to admit lah, for this one I had to look at the marking scheme because I was like, how on earth are we going to answer this with 4 points lah? Okay, so I guess you have to talk about two factors and two advantages. Number one is talk about the mass. Number two is talk about the height. Okay, and then what is the advantage in this way? Okay, so point number one, large mass. Sorry, you know what? Let's not say large mass lah. A player with a large mass has a big inertia. Okay, big inertia means that it is harder to stop. So the advantages of somebody with a large mass is that if he has a large mass, it's a big inertia, therefore it's very hard to stop. So when he's running, when he's running, it'll be quite hard to stop. You need a lot more force to stop this one. This reminds me of an X-Men character called Juggernaut. I don't know why it suddenly reminds me of this one. Yeah, there's an X-Men character in the games, it doesn't appear in the movies, but his name is Juggernaut. And Juggernaut is very famous because, actually he does appear in the movies. But Juggernaut is famous because it's very difficult to stop. Okay, anyway, because it's a big mass. Okay, low center of mass, harder to topple. Okay, so isn't Juggernaut really tall and also really heavy? Correct. But I'm only talking about the heavy part. I'm not talking about the tall part. Okay, let's talk about low height. Okay, low height. Okay, a player with a low height. Okay, as Nathaniel just pointed out now, a player with a low height has a lower center of mass. Center of gravity, sorry. Okay, so in that way, because he has a lower center of gravity, his stability increases, making him harder to topple. Okay. Actually, not topple. Topple sounds so clumsy. Harder to tackle. Yeah, harder to tackle. Okay, because he's more stable, not because he's short terus orang yang tinggi tu melompat di atas dia, bukan begitu he just he's more stable lah. Okay, yes, you are very but unfortunately you're also very light. So again, it's a combination of many factors. Okay, that's why it's called pindik tagap bukan pindik ayu. Okay, pindik ayu is a different thing altogether lah. Pindik tagap lah. Okay, so yeah, a lot of rugby players I know, they are of that category, pendek tegak. They are short and they design, and on top of that, they can run very fast. Okay, I'm sure you can think of people among your friend groups that are in this category. You should encourage them to be rugby players. Okay, low height, low center of gravity, yeah, stability increases, making him harder to tackle. Okay. American football is a sport that involves physical contact that can cause injuries. Oh, I know where this is going. Safety. Okay. 4 protective equipment. Okay, we have the inner part of the helmet, plastic foam, shock absorbing foam. You have the type of shoe, you have the upper body cover, you have the lower body cover. Wow. Explain the suitability so that the injuries to the player can be minimized. Okay, right, let's go. Plastic foam or shock absorbing foam. I'm going to go with shock absorbing foam lah. Okay, shock absorbing foam, this is really a given lah. I feel that shock absorbing foam will be to reduce the impulsive force, okay, by increasing the time of impact. Okay, answer both as a set. I know I'm writing it separately, but answer both as a set. I don't think you will go very far. Okay. Yeah. Next one is type of shoe. I think this one we kind of know where this is going. Type of shoe should be with studs. Yeah, with studs. Okay, and we can use the same answer as just now. Okay, more grip, more friction to avoid slipping. Okay, let me just write to avoid slipping, or more grip. What was the answer we did just now? Oh, more friction. Okay, upper body cover, shoulder pad or full shoulder pad. I find that this is a very interesting question because it's like, do you want half or full? Everybody's just gonna answer full. Okay, yeah, shock absorbing or just normal plastic or polystyrene. Yeah, okay, anyway, full shoulder pad. I think if you want to give in terms of the physics concept, okay, I would give smaller impulsive force smaller impulsive force on the whole body. Yeah, smaller impulsive force on the whole body. The idea is that the impulsive force, I mean, if it's just a normal shoulder pad, like only this part only, okay, only this part only will have a smaller impulsive force. Whereas if you have a full shoulder pad, which includes the front and the shoulders and the front and back, so the whole body experiences a smaller impulsive force rather than just the shoulders. Okay, so protects more parts of the body. Yeah, actually the idea I'm going for is to protect more part of the body to increase the area that is protected. But the problem is, protect more part of the body is not so physics related You want to throw in a physics concept over there. Okay, so that's why I'm writing this very weird sounding answer. Okay, smaller impulsive force on the whole body. You cannot say no impulsive force Okay, definitely smaller impulsive force, but also on the idea of you want to protect the whole body rather than just the shoulders Okay, so again, this is me trying to insert the physics concepts into the reason so that my answers sound a lot more this rather than just this Yeah, but the idea is that you want to protect more of the body. Okay, and Again, I feel that this is not something to panic. Like if you cannot figure out what's the answer, just write protect more of the body. Okay, and then after that, pray very hard that your answer will be accepted. Okay, lower body cover. Again, I feel that this is a given lah. Okay, thigh and knee pad, thigh and knee pad. And I will also say, I will also give the same answer as this. Okay, smaller impulsive force on the whole body. So all in all, to say that the best the best protective gear is the protective equipment L lah. Okay, because L has shock absorbing foam, it has shoes with studs, it has full shoulder pad, and has full thigh and knee pad. Okay. Oh dear, we're slowly running out of time. All right, let us. Are we done? Is this the last one? Oh, we have two more. Okay, two more states to go. Hang in there, everybody. Almost done. I should talk less lah. Okay, SMKA. Oh, this is question number 1. Quite easy. Okay, underline the correct definition for velocity. Velocity is the rate of change of displacement. Be aware of this. Question is saying underline, everybody. I cannot stress this enough. If the question say underline, please underline. If the question say circle, please circle. If the question say tick, please tick. Okay. Rate of change of this one, displacement. If it is the rate of change of distance, it is speed. Okay, bukan velocity. All right, mark on the graph. Now then, tick, tick, tick. Okay, base quantity as shown by the graph. The base quantity is time. Okay, just tick only, jangan pangkah. All right, third, name the physical quantity shown by the gradient of the graph. Okay, VT graph, the gradient is acceleration. Okay, on a side note, if it is an ST graph, okay, the gradient is velocity. Okay, just a side note. Okay, VT graph, the gradient is acceleration. So you write acceleration. Again, everybody, these are knowledge questions. It's either kamu tahu dan ingat atau kamu tidak tahu dan terlupa atau terlupa. So just be very careful. Okay, the answer on question B2 is a vector quantity. Give another example of a vector quantity. There are so many lah. Okay, but our most popular one is displacement. Okay, velocity is also a vector quantity. This is really, a free question because you already know that base quantity is time. Sorry, you already know that time is one of the quantities. You're given velocity over here. Even if you write velocity, the answer will be accepted. Okay, force is also another vector quantity. Banyak vector quantity sebenarnya. Okay, so this is a pretty easy question lah. All right, last one, Terengganu. Terengganu. Oh, question 10. Okay. Question 10. This is follow through. What is meant by impulse? Impulse is the change in momentum. Okay. Okay, explain how the follow through action can increase the distance of the motion. Can I just ask you to refer to the question that we did before? This is the second time we're seeing this question, sorry, the cricket question, which is this. Yeah. Okay. This one. Okay, except that in our case over here, yeah, actually it's the same answer. Okay, the time increases, impulse increase, change in momentum increase. Okay, so I'm just going to say refer to Negeri Sembilan 2023 lah. Okay, so that we don't waste time. As you can see, two states have already come with this one, except that, okay, just to point out lah, okay, this is to increase the distance of the motion of the softball. Just now, when we were looking at this question, it was to increase the impulse. Okay, this one has increased the impulse. Okay, so what you just need to do is the change in momentum results in a bigger distance. Okay, bigger final velocity, therefore bigger distance. Okay, so in this question, okay, I'm just gonna write refer to Negeri Sembilan 2023, except that add in point number 4, okay, dot, a bigger final velocity resulting in a bigger distance. That's it. Okay, just add add the thing into the last line. So so you complete the question, the answer lah. Okay, diagram 10.2 shows a car collision test, a car of mass 1,500 kilograms. That's going to write it here. Hits a wall with a speed of 15. Car rebounds, okay, at a speed of 2.6, okay, meters per second. If the impact time is 150, ms is not a unit, it's a unit, but it's milliseconds. Okay, and how do I know the difference between ms and meters, milliseconds and meters per second? There is no s negative 1 lah. Okay, and at our point, at our stage, okay, when you see ms, it's definitely not velocity related. Okay, it's time. So milliseconds is 150 times 10 to the power of negative 3 seconds. Okay, just to remind you that this is milli. Okay, second thing to take note is right is positive, left is negative. Okay, we need to be aware of this. So, impulse produced in the collision. The impulse produced is mv minus mu. Okay, impulse. Okay, impulse is mv minus mu. So the m is 1500 times minus 2.6. Okay, because we're saying that going towards the left-hand side is a negative velocity. Okay, and then minus mu is 1500 times 15. So you get the answer of negative 26,400 kilograms meter per second. Impulse and momentum have the same unit. Okay, if you want to write Newton second, also no problem. But if you can't remember, just remember the impulse and momentum have the same unit. Okay, the impulsive force acting on the car, okay, is impulsive force, F equals to mv minus mu over t. Now, the good news is you've already calculated mv minus mu over here. So it's negative 26,400 divided by the time. Time is 150 times 10 to the power of negative 3. Okay, 150 times 10 to the power of negative 3, which will give you negative 176,000 newtons. Okay. Impulse and the impulsive force is negative. Yeah, correct. Because it's acting on the car, not the car on the wall. On the car, right? Yeah. So the direction of the force is on the car, which is to the left. It's negative. Yeah. Okay, table 10. Yay, our final question is a table. Okay, different types of hockey sticks. This is that to be used. Oh, this is the other controversial question. Okay. Hockey teams at high level matches. Okay. So material, hockey stick material, length of hockey stick, and the flexibility is low. Okay. Like again, in the case of this is slightly different than the hold on. This is slightly different than the cricketing. Okay. Let's skip the density for a while. Okay, let's skip the density for a while because density and the mass. Just now we skip the mass. So let's skip the density for a while. Let's talk about the material. Okay, you have two choices, either carbon fiber or fiberglass. I think this is a bit weird lah. Okay, I would say that it should be carbon fiber. Yeah, carbon fiber probably. Carbon fiber. Yeah, carbon fiber. Okay, so I'm going to carbon fiber, and the reason for carbon fiber will be stronger material, lasts longer, and all. Dan sewaktu dengannya, just going to give you an additional one, which according to the marking scheme over here, can produce greater impulsive force. Okay, or greater impulse also can. Okay, The length of the hockey stick, either long or short. Okay, the length of the hockey stick should be long. Okay, length of the hockey stick should be long so that it's hockey, right? Yeah. If the length is long, hold on, we are talking about follow through, right? Okay, length of the hockey stick is length of the hockey stick. So greater, yeah. Greater swing distance to achieve greater impulse. Yeah, correct. Okay. Greater swing distance so that you can achieve a greater impulse. Correct, correct, correct. Okay. Third is flexibility. Okay. We want, again, everybody, we want the flexibility. Again, don't think in terms of extremes. Okay. Tidak boleh dinafikan bahawa the hockey stick is not flexible. Okay, it's not like, it's not like the ruler, dia bukan macam ni kind of flexibility. Okay, but in terms of kekerasan kayu, okay, or the stiffness lah, okay, there are some kayus, there are ada setengah kayu kan yang, it's a little bit more flexible than others. Okay, and actually we want a high flexibility, this one. Okay, because if the flexibility is low, kau pukul satu kali saja kan dia senang patah bah. The flexibility is, when you hit it, can it tahan, if it is very low flexibility, means dia pukul sikit saja kan terus patah sudah bah. We don't want it to immediately break. Okay, the short of this answer, the short form of this answer is doesn't break easily lah. Okay, basically it doesn't break easily. That's why we need it to be flexible. But we're not talking about this kind of flexibility. Okay, bukan mana ada kayu hoki jenis begini. Okay, so it doesn't break easily, or in our physics answer, it requires more force to break it. Okay, but that's why it needs to be flexible. Okay, it needs to have a high flexibility. Okay, so in that case, when we look at our answers, we are back with two lah. Okay, either P or R. Do we want a high material density or low material density? Okay. Okay. If you ask me, I would say low. Okay, I would say low because of the virtue that the hockey sticks need to be light lah. When we are talking about the pole vault just now, was the pole vault high or low? Hold on. Pole vault. Pole vault was lighter. Okay, doesn't require much force to lift. Okay, so I would also say along the same lines, you will require a lighter hockey stick. Okay, so sorry. Okay, that doesn't require much force to lift. Basically, it's just lighter lah. Okay, lighter, smaller mass. Then why the cricket bat more mass, right? Yeah, I know. Okay, the cricket bat more mass. Is this the cricket question? No. Hold on. It's a good question, which I'm trying to figure out the answer. Bigger change in momentum and impulse. I know. So, which is why, in this particular question, I feel okay, since it is giving, oh wow, did I just say it is giving? Sorry, since, let's say before we choose the low actually I struggle with this question also, because I feel that both P and R can be the answers. It can be P, it can be R. If you say high material density means heavier. Heavier means you can produce a bigger impulse, which I feel is also makes sense. R also makes sense because you have a low material density, means it's lighter. Lighter means you don't have to use so much force, and you can keep the energy for playing lah. Okay, so actually I feel when then I look at the the marking scheme. The marking scheme chose R. Okay. Actually, I would say I think both P and R can be acceptable answers. But the reason for the high material density would be the same as the cricket bat reason just now, lah. So that you can produce a bigger impulse, you can, generate more change in momentum of the ball. But if you choose a low material density and you give the answer doesn't require much force to lift, it is lighter, it is easier to do the follow through, I also don't think that is wrong. So in this case, I feel that there are two possible answers, okay, both P and R. In the case of the cricket bat just now, oh, sorry, not this. In the case of the cricket bat just now, the reason why I'm choosing a bigger one is because the rest of my analysis shows me that I have to choose W. Although in actual fact, I would have chosen 1.0 kg because it's lighter, we always say lighter means easier to carry, blah, 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 blah. But the reason why I chose a bigger one is because, I want to choose W. So if we encounter this kind of question, okay, and this is everybody's biggest fear, lah. What if we encounter this kind of question and we see that, Allah, both P and R have the thing that I want. So which one do I choose? Do I choose a bigger material density or a lower material density? I feel that you should just make a choice. Okay, and I think both choices can be right. Smaller mass of hockey sticks so that the player can maneuver easily. Oh, okay. Yeah, that's an interesting point. Requires less force to maneuver. Cricket player doesn't maneuver much. Yeah, I guess that can be an answer. But how do you say maneuver? Maneuver has to do with inertia, lah. Yeah, smaller mass means smaller inertia, lah. You can say higher density is stronger. Yeah, you can also say it's generally, yeah, lah. Because the hockey puck not so heavy also can. First of all, this is not ice hockey. This is hockey, lah. Hockey is a hockey ball. Hockey puck is for ice hockey. Hockey ball is actually quite heavy, lah. It's not as heavy as the lontar peluru, but it's also quite heavy, lah. If you throw in somebody, you can injure people, one, lah. Are there any hockey players in our class? No, there are no hockey players in our class. But I feel that, okay, so again, let me address Zaru's answer first. Because you say smaller mass of hockey sticks so that the player can maneuver easily, which I think is correct. Okay, no, sorry, it's not I think. Definitely is correct. But how do you write it so that it is it is physics related, lah? Okay, so if you want to talk about maneuver, sorry for my spelling. Okay, if you want to talk about maneuver, then I would say less inertia, lah. Okay, smaller mass means less inertia so that the hockey stick, okay, is easy to handle. Okay, I'm just improving on Zaru's answer, which is actually a very good train of thought. I think I never thought of it that way, since it's about 150 grams. Yeah, which is not that heavy, okay. Your textbooks are much heavier. Hold on. Okay, but having said that, okay, we still haven't answered our original question, because the cricket one is a higher higher mass. The cricket bat is higher mass because you want a higher impulsive force. Okay, as far as I know, hockey players would generally prefer a lower hockey stick because they have to carry, which is Zare's point, you have to constantly carry the hockey stick here and there. After a while, it can get tiring. In the case of the cricket bat, okay, it is one time you hold the bat and then count him already, after that you have to just throw the bat away and you run or do whatever it is that you do after you hit, so you don't hold it for so long. And so it makes more sense for the cricket bat mass to be heavy. Okay, I think having considered all this and taking all your answers into consideration, actually maybe the better answer would be a low material density. Simply by virtue of the fact that you need to hold the hockey stick for a longer time, as opposed to the cricket bat. Okay, which I hope answers Adele's question. The cricket bat, you don't have to hold it for so long, so you can have it heavy for a little while. Okay, so yeah, I think maybe the better answer will be the better answer will be R lah. Okay, R will be a much better answer. Okay, thanks everybody. I think your input did help me, because I struggled with this question because I knew that somebody is going to ask about the cricket bat, and so I was like, how am I going to answer this? So I was going to answer, I think you should just choose either one lah, because both also make sense. But now that you said that the hockey stick, yeah, people have to hold the hockey stick longer, maybe R makes more sense lah. Okay, it doesn't require much force to lift, or there's less inertia, so that you can handle the hockey stick easily lah, rather than the heavier hockey stick. Yeah. Thank you. Okay. I also need to mention this, but maybe just in passing lah. Okay. Sometimes when I prepare for this kind of classes, okay, usually I tend to write my own answers first, and then only I look at the marking scheme now. And sometimes, of course, in this case, it's a good idea to also look at certain websites. But I would caution this, because there was one time that we did this a few years back, and then different websites give different answers. Okay, of course, Google is our best friend, and now we have ChatGPT. Certain websites will give you certain answers. Certain websites will give you certain kind of characteristics, and other websites may give you a slightly different answer. Okay, so I think that it is always good to get more than one opinion. Okay, and then we hash it out. Okay, we hash it out and we see, okay, which one fits into which situation better. Okay, but all to say that, okay, there are certain questions and this happened with last year's SPM question lah. There are certain questions where the answers may look like they are set in stone, but sometimes if you can argue it in different ways, there may be more than one possible answer for this. Okay, so make a choice. Okay, make a choice according to the best answers that you have. Okay, and then I think that you shouldn't, if you can justify your answer, I don't think you will be penalized for getting the wrong answer lah. Okay, so don't worry so much about this. Okay, all right, I think that's our class for today. I'm so sorry I took an extra 10 minutes of your time, but in our next class we will be discussing light. Okay, so if you can come prepared. If you can't, don't worry about this. Okay, just anggap ini sebagai one study session. The most important thing is, now that you've gotten all the answers, okay, review those answers. Okay, and keep reviewing them. Okay, so that the nearer and nearer we get to the exam, kan tinggal ini kertas-kertas saja yang kamu perlu membaca dan menengok. Alright.